Question number 1 in our study guide is all about piecewise. Now, if we just take a step back, we can appreciate the fact that we are given a graph, which is nice. When we look at questions A and B, we need to realize we're being asked to use function notation to evaluate this graph. So when I look at A that says find f of 4, I immediately know that I am being given an input. Remember that with function notation, we usually write f of x. So if I see a number where x is usually written, in this case 4, I know that I am being given a value for x. I have a value for the input. So then we ask ourselves, well, where should I look? If I have a value for x, we are going to go to 4 on the x-axis and say, I know x equals 4, what's y? When we trace up, y equals 6. So f of 4 equals 6. And we're done. B says find x. Right away, if it says find x, you should realize, well, I don't know x. What do I know? It says find x when f of x equals 3. So there's two approaches. One, if it says find x, well then if I have to find x, I don't know it. I must know y. Another way to approach it, we know that f of x is the same thing as saying y. So I'm being told y equals 3. So if y equals 3, we go to 3. Here's 1, 2, 3. Here's 3 on the y-axis, and we ask ourselves, when y equals 3, what is x? Well, I see I have an x value right here, but also if I trace over, here's another one. So we have two answers. So if we look down, when x equals 1, y is 3. So x equals 1. And, see where this is, -5. And how you write your answers, it's up to you. I would be fine if you wrote x equals 1, comma, -5 as like a list, or -5, comma, however you put x equals 1 and x equals -5, that is good. Next, we're asked, determine the increasing, decreasing intervals. So an important note here, we always read graphs left to right. So if I read this left to right, this is decreasing left to right. Here I am increasing. So if we color code these, increasing, here is my increasing ray. We're asked for the interval. Now in class prior to this, we were using like combinations of brackets and parentheses for increasing and decreasing. After talking with Ms. Bump, who also teaches honors, for increasing and decreasing intervals, we're just going to use parentheses always. If on the test tomorrow you use bracket or a parenthesis, I'm not going to take points off, but watching this video, take note, I'll accept just straight up parentheses. So this interval is increasing from -1 to infinity. -1 to infinity. There are no other increasing intervals on this graph. So now we look for decreasing. Again, left to right, decreasing, going down. So there is my decreasing interval. Let me kind of tighten up the highlighting on that. And we need the domain of that decreasing interval. I come in from the left, I hit an arrow, so I know that's -infinity. Don't be fooled by the fact that the arrow is going up. The y values are increasing, but we don't care about the y values when we're talking about intervals, increasing and decreasing intervals. We're looking at x values. So yes, y values are getting bigger, but think to yourself, as those y values get bigger, as this line continues to the left, my x values are going towards -infinity. That's where this -infinity comes from. So -infinity, when I come in from this direction and I look for the point coming in from this side, I am at -2. Again, before when we were talking, we would say solid dot, put a bracket, but for intervals, I'm okay with just increasing and decreasing intervals. I'm 100% okay with all parentheses. In future years, if you watch this, what I just said, you can ignore, because starting next year, I will always make sure to say increasing, decreasing intervals. We'll just always use parentheses no matter what. Little side note. Okay, write the piecewise function. I know I'm going to have two pieces. To make this easier, I'm going to get rid of my highlighting, bring it back down to a bare graph. You don't need to erase. If you've done something, leave it. But for the notes, I would like us to look at a plain graph. So the strategy in class, we numbered these. So I'm going to call this piece 1, and I'm going to call this piece 2. And really think back to your Algebra 1 days. If this was a full line, and I asked you to write me the equation of the line, you would be looking for 2 pieces of information. You would be looking for m, which is the slope, and b, which is the y-intercept. Slope and y-intercept. It's exactly what we're going to look for each piece. So off to the side, in this case below, I'm going to take some notes. So for piece 1, I am looking for the slope. You could choose 2 points and calculate, but if I can count, I would like to count. So if I start at this point and I count vertical change divided by horizontal change, rise over 1, I would go up 2, left 1. Let's double check though. Does this really work? Let's see. Up 2, right 1. Up 2, right 1. Yes, it does. So up 2, right 1 translates to a positive 2 divided by 1, which is 2. Now, if when I said up 2, right 1, you automatically knew it was 2, by all means, you can skip what I did with the arrows. But if you know you're someone who tends to make mistakes with how you count or dropping negatives with the slope, which I think I did. What did I do wrong? Caught it. It was not up 2, right 1. It is up 2, left 1. So the reason I knew I made a mistake, which is a good teachable moment for everyone, is I have a decreasing line, but what kind of slope did I get? I got a positive slope. That's a problem. That's what set me back to looking. So now let's fix it. Up 2, left 1 would be 2 divided by negative 1, which is negative 2. Okay, so I have m. We've got m. We mentally check that off. Now I need b. Well, I don't see where this piece crosses, and it's a piece. It technically is not. But to get the correct expression, I do need to say what b would have been. So instead of counting up to left 1, let's count from here down to right 1, down to right 1. And oh, check that out. It crosses nice. So I know b is negative 7. So now that I have m, and now I've got b, I can kind of mentally check off b, we can actually write the first piece. So I have f of x equals mx plus b will translate to negative 2x minus 7. M is negative 2, so negative 2x minus 7. Now we need to talk about the domain of this piece. So some of us are very comfortable with interval notation, which is great. So if I, for example, asked you on what interval is this decreasing, I know you would tell me negative infinity to negative 2. But that is not how we write our restrictions. I need x and then some connection to an inequality. So instead of seeing this as an interval, I really want to see this as an inequality on a number line. And if I see it that way, I see that negative 2 is my largest x value, and it's left forever and ever. So x is less than or equal to negative 2. That is my restriction. I know the or equal to part because that's a filled in dot. Because this is array, I know I'll have x is less than or equal to or greater than or equal to a number. If I saw a segment, I know I would have x between 2 values, but there are no segments in this piece. We are now ready to talk about piece 2. So for piece 2, the process does not change. We're still mentally looking for an m and a b. So let's go find m first. Counting from here, I would go up 2, right 2, is what I saw first. Maybe you saw up 1, right 1. Let's see if that still works. Up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. So that works. So up 1, right 1 is a positive 1 divided by 1 equals 1. Should I get a positive slope? Yes, I should. It's an increasing piece. So we've got m. You can mentally check off m. Now I need b. This piece is really nice because I am given b. I clearly see that this is crossing the y-axis at 2. We are ready to write the piece. So mx plus b will be 1x, or x, plus 2. Whether you write that in 1, it's up to you. If you want to, you can. Now I need to ask myself, where is my restriction? My restriction starts at 1. X is greater than 1. I do not have an or equal to because this is an open circle. And I'm done. I had 2 pieces on the graph. I have 2 pieces in my piecewise function. I'm all set. Okay. Domain and range. Now the domain on this one is interesting. And as I was talking, I was like, ooh, look at the domain on this graph. The reason I say that, and what you might also see, is that do you have a graph, any piece of the graph in between -2 and 1? I'm all set. From negative infinity right up to -2, there's no gaps. But from -2 to 1, there is no graph. And then the graph picks up again at 1, even though there's an open circle, 1 to infinity. So we really are going to have 2 pieces. In terms of the domain, this first piece will get me negative infinity to -2 with a bracket. And then this piece, this second piece, is with a parenthesis, -1 to infinity. I need to put a union between these 2 pieces. So my domain is negative infinity to -2, union -1 to infinity. Let's talk about the range. I have no arrows pointing down. So that's one thing to check for. That's the first thing I looked at. Do I have any arrows pointing down? I do not. So I definitely will have a restriction coming in from the bottom here at -3. And I check, check, check. Now here I have an open circle, but this value over here fills this one in. And I have arrows, even if I just had 1 is enough, but I actually have 2 arrows that are both going up. So I know that my range will be from -3 to infinity. My range -3 to infinity. The reason we have a bracket is because this is a solid dot right there. So number 1 was a nice summary of how to write a piecewise function. Number 2 says graph, and we definitely had a nice fixed approach for graphing. Our first step for graphing is going to be writing the piece. So my first piece is -3x plus 4 when x is less than -1. And I'm going to put that in a box just because I think it helps it stand out. Make sure we have enough space. So I wrote my first piece. To graph any line, segment, ray, we need to have 2 points. And we are always going to look to the restriction for as many points as we can, for as many x values as possible. In this case, I only get 1. So here's 1. Let's work with this one first. So we're going to do -3 times -1 plus 4. We're substituting in -1 here. That gets me 3 plus 4, which is 7. And if we write our ordered pair, x comma y would become -1 comma 7. Now, it's great. I have 1 point. I still need 1 more. We are still going to use the restriction to help us out with that. This says x is less than -1. So I can pick any x value I want less than -1. I wouldn't go crazy. Don't pick -1,000. We need to pick something that will fit on the graph. So I choose -5. But maybe you picked -3. Maybe you picked -7. Our graphs should still come out looking the same. So I'm going to have -3 times -5 plus 4. So I do -3 times -5, 15 plus 4, 19. Is that going to fit on the graph? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nope, no good. We picked something that technically works, but it's too big for our graph, so we should pick something smaller. Maybe negative 3? Let's try negative 3. So I have negative 3 times negative 3 plus 4. Let's check. Negative 3 times negative 3, 9 plus 4. Ooh, 13. 1, 2, 3, 4, 5, 6, 7, 8. Ah, still too big. That's why we do math in pencil. All right, back it up, back it up. Maybe I'm going to have to pick negative 2. Let's try negative 2. So this is showing you may have to kind of guess and check a little bit. Sometimes we pick a good one right away, but sometimes we might have to try a couple. So let's see. Negative 3 times negative 2 plus 4. Negative 3 times negative 2 is 6, plus 4 is 10. That's going to fit. Just going to fit. As an ordered pair, negative 2, 10. And we're ready to graph this piece. So we're going to graph negative 1, comma 7. And this came right from the restriction, so we should check. Based on the restriction, should this be an open or closed circle? Well, I see it strictly says less than, so I know it'll be open on negative 1, comma 7. My next ordered pair is negative 2, 10, and this is on the ray, so I know it'll be solid. My ray will start here, and it's going to go forever and ever through that point. And I have graphed my first piece. Very good. Let's work on the second piece. The process is the exact same. We're going to write the piece. So our next piece is x minus 5, where x is greater than or equal to negative 1 and less than 6. Now this is nice because I have a segment, so I actually get both the x values I need straight from the segment. I'm going to use x equals negative 1, x equals 6. Substituting them in, negative 1 minus 5 gets me negative 6. So I get negative 1, comma negative 6. And here we're going to do 6 minus 5, that's 1. So my other ordered pair is going to be 6, comma 1. Something I saw a couple people doing, and I'm going to just mention it in case it helps you, you can actually decide open or closed before you even plot. Like this one, right? X strictly less than negative 1. So I knew when I plugged in negative 1, this was going to be open. That's a bad open circle. Open. And this one is on the ray, so it's going to be closed. Here, both come from the restriction, so we have to pay attention. On the negative 1 side, this is or equal to. So I know that'll be solid. 6 came from this right side. That's strictly a less than symbol, so I know this will be open. If you like doing that, do it. If you don't like it, don't worry about it. Don't do it. But it may help. So we're going to plot a solid circle on negative 1. 1, 2, 3, 4, 5, 6. Solid circle there. And then 6, comma 1. 1, 2, 3, 4, 5, 6, comma 1. I made a mistake. It's late. Sorry. Negative 1. Down. 1, 2, 3, 4, 5. Oh, okay. Crisis averted. And then 6, 1. 1, 2, 3, 4, 5, 6. So I was going a little faster, and then by accident, I graphed 1, negative 6. It's supposed to be negative 1, 6, but we fixed it. So check, is this a ray or is it a segment? It's definitely a segment, which means I'm only graphing between the 2 points. No arrows going anywhere. And all we were asked to do was graph. So I don't have to worry about domain and range. Just a little side note, if we were asked to do domain and range, when I come in from the left, I hit an arrow, and I'm checking. I do see a hole here, but this filled in hole fills in that one. Keep going, and I'm stopping right here at 6. So if I did ask you for the domain would be negative infinity to 6. This gets a parenthesis because it's open. The range, we definitely have a gap, right? because the range for this piece is -6, 1, 2, 3, 4, 5, 6, -6 to 1. So -6 to 1. Remember, we're looking at y values right now. Union, and I go up, this is 7, 1, 2, 3, 4, 5, 7 to infinity. Any questions on the domain and range of this graph? Let me know tomorrow. Very nice. Number 3. For each function listed, provide an example as an equation and as a graph. The graph does not need to be that of the equation, meaning you can write a linear function. What you write here doesn't have to match what you graph. So let's work on this. Linear function is anything like y equals mx plus b. So I could say f of x equals 10x plus 3. The key is that x is x to the first. Use yellow. That's what makes it linear, is that there's an invisible 1 here. So you could have written y equals x. That's the parent function. And in terms of a graph, any kind of straight line is a linear function. Making sure you have arrows on both ends. So for linear, highest, just a little note, power is x to the first. We just usually don't write the 1. There's no square roots, there's no other exponents, there's no denominators, just straight up linear function. Constant function means just g of x equals a number, no variables. So let's say g of x equals -4. That will be a horizontal line through 1, 2, well, I'll draw it and I'll move mine. Oops. 1, 2, 3, down 4. Horizontal line through -4, and I am done. Again, notice, no variables here, just a number. Square root function means a function with a square root. So, for example, play around with the letters. Let's say m of x equals, I don't know, -1/3, just totally making this up right now, square root of 2x plus 5. That would be a square root function because it has a, drum roll please, has a square root. The sketch of a square root function looks something like a start point and an arc. The start point could have been over here and going that way, but it has a clear start with an arc in a particular direction. Quadratic function, anything with highest degree of 2. So, let's say n of x equals 5x squared minus 3. Notice, highest power is 2x squared, makes it quadratic. You want to write that out for yourself? Degree means highest power, so degree or highest power is 2. And again, no square roots, no denominators, nothing crazy other than my little, nice little x squared right there. We all are very comfortable, I hope, with quadratics in that we know they are a U shape. That U could open up, could open down. I'll make this one opening down. Quadratics are U's. Very good. Exponential functions. I'm going to give you a second. If you haven't actually gone and gotten out your parent chart function, I'm realizing you could have been using this as a reference the whole time we've been talking. So I will wait a second while you go get your parent. For example, r of x equals 2 times 3 to the x. As soon as you see x as a power, we know it's exponential. Exponential functions are very pretty. They look like a curve. That curve could also start here and curve down that way as well, but it's just one nice curve. Cubic functions. As soon as you see something referring to a cube, we should think to the third power. So quadratics with highest power is 2. Cubic, highest power is 3. So let's say f of x equals 18 x to the third plus 5x squared minus 2. I don't know. As long as you make the highest power 3, you can do whatever you want. Notice highest power is 3. Cubics have a bump in them, like so. It could also look like this. It's got 1, 2 turns. There's 2 turns in the graph. 2 turns in the graph. Two more to go. Absolute value, we should be experts. Experts. So I have g of x equals anything you want, as long as you've got some giant, no, don't make them that big on the test, but you get my point. Absolute value bars going on. We all know that absolute value looks like a V. That could be a V opening up, down. Those are the two choices. No sideways, up or down. Cube root is a radical, but instead of a square root, it's a cube root. Meaning we have a little 3 up there. And again, it's whatever you want. Just make sure that you see that 3. Cube roots are an odd root. We will call odd roots do not have restrictions. An odd root kind of looks something like that. Make it a little better. So be careful tomorrow that on the test, if I ask you to match something, you don't confuse cubic with cube root. Here's cubic, 2 turns like so. Cube root has more of that curve going on. But I just realized I drew one that looks like it wouldn't pass the vertical line test. Let me fix that. Very nice. Let's move away from function names. Write an absolute value function with the following roots. And this is a great hint to sketch the graph. So no real roots. Really, think about what that means. To have no roots, I need to be shifted up and opening up, or shifted down and opening down. So I'm just going to go with the first option I said, where I want it to be shifted up and opening up. Well, let's first talk about opening up. That's going to be a function with a positive a value, whatever you want it to be. This is just a rough sketch here. So a positive a value. Whether or not it's shifted left or right, it does not matter. In this case, I shifted it left, so that means it's going to be x plus, well, I'll make it up, 8, let's say that. So shifted left 8. Remember, that would be x minus a negative 8, which is why I'm saying it's a shift left. But irrelevant. I could have just put nothing here and just closed the bar. The key piece here is that shifted up. So this would be one that has no real roots, because I have built a function that is opening up, because this is a positive a value, and shifted up. To make this opening down and shifted down, we would just make a negative and put minus 5 instead. One real root we had talked a little bit about in class. I need something that is sitting directly on the x-axis. That could be sitting on the x-axis opening up or down. Just because we did one opening up, let's do one opening down. I keep drawing one with a shift left. Let's do one that's shifted right. Again, your sketch does not need to match, but for the sake of the visual, I will. So let's really think about what this means. I need to have, doesn't matter, it could have opened up or down, so that's irrelevant. A does not matter, so make your choice what kind of A you want. I'll pick a negative A, why not? So I'm going to say g of x equals negative 3. So I'm more kind of thinking of this one. We're going to give it a horizontal shift to the right, let's say 6, why not? But if I wanted to sit right on that axis, I am not going to have any kind of vertical shift, no vertical shift. So notice, I have put nothing here. That's the key to having one real root, is that you have no vertical shift. It doesn't matter up, down, if you shifted it left or right, irrelevant. The key is no vertical shift. Very good. Two real roots. Two real roots. Well, for two real roots, think about what that means. I do need to shift it up or down. So let's say I shifted it down. Let's say my vertex is down here. Then if it's shifted down here, I need it to open up for it to cross twice. If I put my vertex somewhere up here, cool, that's a vertical shift. Now ask yourself, how do you have to make this open for it to hit twice? I need it to open down to hit twice. So there are options. Let's say we model this one. So I'm going to say m of x equals, I need a negative a value because I'm opening down, so maybe negative 1/2. For this one, I have to be shifted up. So keep that in mind. I did draw a horizontal shift, so I'll say x minus 4. Now this is the key. Shifted up 10, for example. So the key to this one is that I am saying it's opening down, shifted up. So I shifted the graph up, and it's opening down. It hits twice. Send me a remind if you're not sure if you write one that's correct or not, okay? I don't want to over-talk the idea. So I'm just going to move on to number 5, but hopefully this conversation helps right here, and then you let me know if you have any more questions. East Hartford High School wants to build a new student parking lot. The outline below represents the proposed shape of the parking lot. So I have 2x minus 3 yards here, x yards, x minus 5, 3x plus 2. Write an expression for the perimeter in yards of this proposed parking lot. Well, I know perimeter is adding up all my sides, but I think I'm missing a side. I got this side, I got this side, I have this one, I have this one. I don't have this one. I do know the whole right here. I know that this whole side is 2x minus 3. And I know this piece is x minus 5. So if I subtract this piece from here, I should get what I need. Notice, really make sure you use parentheses, because now I get 2x minus 3 minus x plus 5. And now combining my terms, x plus 2. That's correct. Let's try that again. 10x minus 2 equals 558. For the record, it is currently 4:52 p.m. and Miss J needs another cup of coffee. So bear with me. Don't be like, oh man, Miss J, I had this. I'm sorry. Bring it in tomorrow. I'll give you a lollipop. All right. So I got 10x equals 560. It's actually working out nicer. So we're going to divide by 10. Divide by 10. X equals 56. I can just imagine. Man, I had that, Miss J, and I erased it. I'm sorry. Okay. X equals 56. Let's do this again. So 2x minus 3. So 2 times 56 minus 3. 2 times 56 minus 3 is 109 on this side. This will be just 56 right away. 56 minus 5 gets me 51. Hey guys, look, we have an expression for this side. How exciting. 2 times 56 plus 2. 2 times 56 plus 2, 114. This side, x plus 2 will be 56 plus 2, 58. This side, 3 times 56 plus 2, 3 times 56 plus 2, 170. And we can actually do a little bit of a check. So I should be able to add up all of these numbers, and I should get 558. So 109 plus 56 plus 51 plus 114 plus 58 plus 170 equals 558. Yay! Okay, C. Write an expression for the area. So I recommend kind of imagining this in two pieces. I'm just going to resketch to the best of my ability. Imagine that's all square. So we're going to actually cut this in pieces. This is going to be one box, and this is going to be another box. You could have made this a box and this a box. There's two ways to do it. Now I know the expression of this side is 3x plus 2, and this is 2x minus 3. So for the green box, we're going to do 2x minus 3 times 3x plus 2. That'll get the area of the green box. Let's do that first. So I get 6x squared plus 4x minus 9x minus 6, which is 6x squared minus 5x minus 6. So that's the green piece. I don't want to write it here because I don't want to add it to the picture, but we've accounted for all the green space. What about the red space? Well, I know this is x, right? If I look up here, x, and I know this is x minus 5. That's all I need for that piece. So for the red piece, x times x minus 5 gets me x squared minus 5x. And that got me the red piece. So now we can add these together. So it will be 6x squared minus 5x minus 6 plus x squared minus 5x. Combining like terms, 7x squared minus 10x minus 6. So just to recap the big idea, the big idea is take your shape and can you split it into two rectangles that you can work with. We had the width and the length of the green piece multiplied to get this result. Then we had the length and width of the red piece multiplied and then added our two results together. Number 6, the town of East Hartford uses a piecewise function to determine the monthly water charge for a consumer. Let W represent the cost of water and G number of gallons in thousands used by the customer. So to help myself out, I'm still just going to write off to the side. G is number of gallons. W, cost of water. W of 4.7 and explain what it means. So again, remember your function notation. I am being given a value for G, and G is all about gallons, and I can go up here and say, okay, well, where does 4.7 fit into my restrictions? Is 4.7 between 0 and 4? No. Is 4.7 between 4 and 7? Yes, it is. So W of 4.7 equals, and we're going to plug it into this, 5.32, 4.7 minus 4 plus 20.29. Nobody has time to do that out by hand. Let's use our calculator. So 5.32, parentheses, 4.7 minus 4, close parentheses, plus 20.49 equals, I get 24.214. The meaning, remember, G is gallons. So 4.7, am I saying 4.7 gallons? Does that sound right? Well, let's check. G is the number of gallons, but ooh, take a look, in thousands. So to figure that out, we're going to do 4.7 times 1,000. So this really means 4,700 gallons. So 4,700 gallons of water will cost $24.21. How many gallons of water were used if the customer's water bill was $18.11? Well, let's reason on this. 24.21. Does that help us out a lot? Not really, because that didn't come from plugging in the largest value. But maybe we kind of think, well, let's see what happens if we substitute in 7, because you can't assume that this is B. This is not evaluated. So your choice would be to send this in, combine like terms, or use your calculator really quick to plug in 7 and see what we get. So I'm going to do 5.32 times 7 minus 4. I'm plugging into the middle piece right now. I get 36.45. And when I plug in 4, I can hit second entry, so I don't have to do it all over again. 20.49. So that did work, because when I plug in 4, 4 minus 4 is 0. But you could just plug in 4. If you substitute in 4 in your calculator, this gets you 20.49. So 1811 definitely does not fit in the middle piece, because it's not between 20.49 and 36.45. So right away I know to answer C, I'll be using this first piece, because that's where the cost of 1811 sits. So it's going to be 1811 equals 4.76 G plus 1.45, and we're going to solve that. So I'll subtract 1.45, subtract 1.45, 18.11 minus 1.45, 16.66. Divide by 4.76. I got 3.5. G equals 3.5. But we know we're not done because, again, G is in thousands. So 3.5 times 1,000 is 3,500 gallons. So if the bill was 1811, it means 3,500 gallons of water were used that month. Because remember, this is a monthly bill. It's a lot of water, but it's a big building. So if the bill was $18.11, it means 3,500 gallons of water was used. Was makes more sense. Was used. Who knows? Was or were? I don't. We'll go with was. Was used that month. Number 7. So number 7 is a blast back to that piecewise video I had put up. According to the U.S. Census Bureau, the population of Hartford, Connecticut was 79,000 in 1970, and then from 1970 to 1995, it grew at the average rate of 1.64 thousand people per year. After 1995, the population of Hartford grew at an average rate of 5.37 thousand people per year. Find a piecewise function, population P, as a function of the year T. So your choice, it didn't say population in thousands, but I'm going to add that. Just in case you choose to do that, I'll do it too. So we're going to alter population P in thousands. So P, or let's start with T. T is number of years. Let's define a 0 year. So T will be the number of years. 1970 is my 0 year. 1970, number of years since 1970. And population, we said, will be number of people, but not just number of people. We're going to say number of people in thousands. Try to make this a little smaller. Okay, so I have my variables. Now let's talk writing our piece. So we talked in the video last time, the first piece comes nice. So P of T equals, let's see, 79 is my initial value. 1970, so this is my 0 year again. So in this amount of time, average rate of growth 1.64, and it says growth, so I know positive. So 1.64 T, and then in that 0 year, the population was 79,000, so plus 79. I need to know how many years. I know 0 is 1970, but what about 1995? In my calculator, if I do 1995 minus 1970, I get 25. So I know that for this first piece, my domain restriction will be 0 to 25, because 1995 is 25 years after 1970. And if you don't see that right away, that's okay. Subtract, and you'll get 25. Do 1995 minus 1970. Now for the next piece, we have some math to do. Remember, it doesn't make sense in the real world, in this next piece, to say that all of a sudden the entire population of Hartford went back down to 0 and grew again. No. In 1995, there was a certain amount of people living there. So what we're going to do to figure that out, we're going to take 25 and we're going to figure out P of 25. For space, I'm going to do it up here. P of 25 equals 1.64 times 25 plus 79. Let's get those calculators going. 1.64 plus 25 plus 79. So it wasn't coming out right. I didn't think this was supposed to be negative, and I checked and I made a calculator error. This should come out to be 120. So y minus 120 equals still the same slope, 5.37 x minus 25. Let's try that. So I have y minus 120 equals 5.37 x (134). It's still going to come out negative. All right, that's what I got. Hopefully you got the same thing. Based on your model, what was the population of Hartford in 1980? So we need to figure out how many years after 1970 is 1980. That's 10. 10 falls into the first piece, so P of 10 equals 1.64 times 10 plus 79. So if I do that, times 10 plus 79, I get 95.4. Multiply that by 1,000, and I know that is 95,400 people. When did the population grow to 200,000? Well, I definitely know it's going to be after this piece, because here, when I left off at 25 years after 1970, I know my population was 120,000, and 200 is bigger. So we're going to be using the second piece. So we're going to say 200 equals the second piece, 5.37 t minus 14.25. I'm going to add 14.25 to both sides. So 214.25 equals 5.37 t. Divide by 5.37, divide by 5.37. 214.25 divided by 5.37 is 39.89. If I go to 3 decimal places, 898. So even though this is 0.8, it's still going to happen in the 39th year. So 39 years after 1970, (2009), and we're done. On to function operations. So I know that I can rewrite this as g of x minus f of x. So that's going to be my first function, 3x squared minus 5x plus 11 minus. Now I have to make sure I put this second function in parentheses. That's key because I need to distribute the negative. So 3x squared minus 5x plus 11 minus x plus 4. Combining like terms, we'll get 3x squared minus 6x and then plus 15, and we're done. F of x to the third will be x minus 4 to the third. I would take 2 of these on at a time first. So if I just do this piece, I know I'll get x squared minus 8x plus 16, and you can do that out with arrows. I still need to multiply by 1 more x to the negative 4. I mean, x minus 4. I like to write this in the front, so I'm just going to rearrange it. And same thing, we're going to use arrows again. So that would be x to the third minus 8x squared plus 16x. And now we'll switch to distributing -4. So minus 4x squared plus 32x minus 64. And now we just need to combine like terms. So I have a -8x squared, a -4x squared. This will become x to the third minus 12x squared plus 48x minus 64. And I'm all set. Composition. This is g of f of 2x plus 3. This is an example where if there's something I can do on the inside, I want to do that first. So I can figure out what f of 2x plus 3 is. So that's where we're going to start. There's something I can do with that. So f of x is x minus 4. We're going to do f of 2x plus 3. So wherever I see x, I plug in 2x plus 3. That's 2x plus 3 minus 4, 2x minus 1. Now we're going to take this result and substitute it into g. G of x says 3x squared minus 5x plus 11. So g of, I think I need to go on to another page. 3x squared minus 5x plus 11. X squared minus 5x plus 11, and we're doing g of 2x minus 1. We're doing g of 2x minus 1. So that'll become 3 times 2x minus 1 squared minus 5 times 2x minus 1 plus 11. Now this piece is one that we always recommended we do not in the problem. So we're going to take this out and work on it. 2x minus 1 times 2x minus 1. Using our arrows, we get 4x squared minus 2x minus 2x plus 1. 4x squared minus 4x plus 1. So now that that's all set, we can bring it back in. So this will be 3 times the result you just found. 4x squared minus 4x plus 1. Distribute 5, so that becomes minus 10x. Distributing a negative 5, excuse me. Negative 10x plus 5 plus 11. From here, it's purely algebra. Send in the 3, 12x squared minus 12x plus 1. Bringing everything else down. I can make that 16. And now we just need to combine like terms. That's it. So the strategy on this one, there was something I could do on the inside, so I did that first. So if you see f of like x minus 5, or f of 5, f of 3x plus 2, if there's something inside you can do first, do it first. We got 2x minus 1, and now we needed to plug that into g. Now this was not enough space for me to do that, so I did it on a separate piece of notebook paper, so to speak. I still made sure I wrote my guide, right? Ultimately, we're plugging this into g, the result. So g of x equals 3x squared minus 5x plus 11. Substituting in the 2x minus 1. So wherever we saw x, we plugged in 2x minus 1. And after that, it was straight up algebra. Very good. Final section of the review. Blast from the past, domain restrictions. So, quick note, even roots, set what's under the root, whatever that may be, greater than or equal to 0, and solve. So in this case, what's underneath the root is 2x plus 10. All I care about is what's underneath the root. So we're going to take 2x plus 10, greater than or equal to 0, subtract 10, subtract 10. 2x greater than or equal to negative 10, divide by 2, divide by 2. Notice, the inequality sign is not going to change here because you did not actually divide by a negative. Yes, the 10 is negative, but you did not divide by a negative. So domain, all real numbers, x greater than or equal to negative 5, and we're done. B is a quadratic, it's a polynomial. All real numbers. Again, we kind of reasoned when we finished up this section last time that if it's not an even root and it's not a rational, it's not a rational function, there is no restriction, all real numbers. This last one, rational function. Cannot divide by 0, take denominator, set it equal to 0, and solve. The answer, or the domain, will be all real numbers x not equal to whatever you find. So here, all we care about is the x minus 3. Who cares what's up top? No influence on the domain. So I take x minus 3, set it equal to 0. That gets me x equals 3. My answer, though, is going to be all real numbers x not equal to 3. And we are done. Yay! So you don't have to watch this whole video. I hope you realize that before you hit play, okay? Just go to the piece you need, all right? Have a great day. I'll see you tomorrow. Send me any questions on Remind. Good night.